Dear students, in the previous video we discussed about pumping lemma to prove that it is not a regular language. In this video we are going to discuss about closer properties of regular language. If you say regular language, what is its property? Closer in the sense combination of two languages. Before entering into the property, I want to give some introduction about the need of this property, because basically property wise nothing is there, very simple statements are there, but you may have a doubt why we need this. Consider two languages. There is a language L1, there is a language L2. Have a look on this language. AB at the end, AB at the end, AB at the end, which means ending with the AB, starting any number of B's. Am I right? Yes. Starting is CD, ending, yes, come on, you got it. Any number of D's. So what is its expression? Ending is AB, starting B star. Here, starting is CD, ending can be anything, no. Ending can be any number of D's, so it is D star. Now there are two languages and their expressions. Now the question here is, what is DFA for this? Ready? AB, B star. Finite automata can be constructed. Yes, I can construct. So it is a regular. Who is a regular? L1 is a regular language. I can also conduct or design finite automata here. Done. CD. Ending is D star, that is a self loop. Finite automata possible, that is DFA possible. Finite automata can be constructed, hence it is regular. Who is regular? L2 is also regular. Now the statement is, sir, L1 is regular, L2 is regular. In case, if I combine L1 and L2, if I combine expression for L1, that is R1, and expression for L2, that is R2, if I combine, how you combine, I don't know. That can be union, that can be concatenation, that is star, R plus, R dot, I don't know. If you combine, is it the result is a regular? Which means, can I have finite automata for the result? If it is done, it is closer. So, can we have a single finite automata for both L1 and L2 is the question. Now, we will have some example. The same work I took, whatever may be discussed, let us do case 1. Let us combine by concatenation. L1, L2, which means R1 dot R2. Okay. So, R1 dot R2. Let us have a look. This is R1 expression. This is R2 expression. Can I have dot like this? Yes, possible. Now my question is, can you have a diagram like this? Yes, obviously possible, you know. This is diagram for first group. This is diagram for second group. Dot means what is the meaning? Concatenation, one after other. If it is plus means what is the meaning? Union, one below other. Now dot means one after other. So join. It is more than enough. Now the question is, finite automata possible for combination of L1 and L2. So this L1 and L2 is closer under concatenation. This is the meaning. Sir, you told for concatenation. Can you tell for union? Yeah, for single finite automata exists. Okay. Can you tell for union? Case 2. Let us have expression A star. Let us have expression B star. Draw machine for A star. Ready? Done. A, one backward loop, one forward loop. I hope you remember. This is A star. What about for B star? Come on. B, backward loop, forward loop. This is finite automata for A star, finite automata for B star. Sir, if I want to do concatenation, one after other. If I want to do union, one below other. Let us try. What is union? A star plus B star. If you can draw, closer under union is possible. Yes, I can draw. Possible. single finite automata exists for L1 union L2, which means L1 dot L2 also possible, L1 union L2 also possible. So it is closer. Closer in the sense combination is possible. Let me go to the property. This is the concept. Based on this property, I am going to. Property is nothing, just a statement. Closer under union. If a language is L1 and L2, and if they are regular languages, then L1 union L2 is also regular. I want to prove this. What is the proof? If the regular expression for above language is R1 and R2, already we discussed R1 and R2. If R1 union R2 is regular, R1 union R2 is regular, I have just proved in the example, case 1 it is. So what about L1 union L2 is also regular? Sorry, it is case 2. That is union, plus. That's all. So it is proved. What is concatenation? This is case 1 example I discussed. Assume there is L1 and L2. And if I want L1 dot L2, then what is regular expression R1 and R2? If you can have R1 dot R2 is regular, then L1 dot L2 is also regular. Just now we discussed in case 1. So it is also possible. Now let us go for star. If there is a regular language L, then L star is also regular. How come? If there is a regular language L, what is its expression? R. Can I have R star? Yes, possible, sir. What is the diagram for R star? Self loop. If finite automata is there for this, for R star also finite automata. So it is proved. That is the meaning. Okay. Next, complement. Fourth property onwards, little bit difficult is there, but it is manageable. Complement, opposite. Whatever a finite automata is accepting, others should not accept, it should reject. Consider one finite automata. Consider another finite automata. Both are complement to each other. What is that? Whatever the final state here, it is not a final state here. That's what it's complement. Whatever accept, he won't accept. Whatever he accept, he won't accept. Above DFAs are complement to each other. Is it complementation is regular or not is the question. That is, the language accepted by first DFA will be rejected by the second DFA and vice versa. Language L is regular, then its complement is also regular. That is the statement, nothing else. Now, what is the statement here? Language L, it is having a machine equation Q, Q naught Q1, sigma, 0 and 1, delta, transition. If you give A 0, it is going to A. This is called delta. Q naught is initial state A. F is final state, that is B. Machine equation for L is possible. What is machine equation for L dash? Possible. The same A B here, the same 0 1 here, the same transition here, the same initial value is here. But what about final? Its negation is here. That is what? Q minus F. Opposite. That is what? Negation. It's possible. There is no difference between the machines M and M dash except the final state. Hence, both are regular. That's all the complement. What is property number 5? Intersection. Little bit calculation is available. Let us see what is that. L1 intersection L2 is regular. I want to prove. L intersection means common, merging. If there is a language L1 with machine Q, sigma, delta, whatever may be, and its machine is here. Similarly, I do have L2 with machine. L2 with machine equation Q2 sigma delta QF. What is this Q2? Number of states, alphabets, transition function, and it is initial state. Here it is A, here we are going to do C, and this is nothing but final. Here it is B, and here it is D. That's all. So, sorry, final state is C here. Now, M1 is machine for L1. M2 is machine for L2. What is L1 intersection L2? What is L1 intersection L2? Which is combination of these two machines. How we are going to construct? Have a look. It's very complicated. Whatever M1 and M2 I decided, I have drawn. Now I am going to draw L1 intersection L2. How? Carefully see here. I would like to do intersection here. What is machine M? Intersection of this AC, AD, BC, BD. Total force. Ready. Come on. AC here, AD here, BC, BD here. That's all. Combination is over. Next, what about its final state? What about its final state? Who is final state here? B. Who is final state here? C. What is intersection? Combination of both B and C. BC is the final state. That's all. What about initial value? Q. Q1 comma Q2. Who is initial here? A. Who is initial here? C. Arrow mark. Okay. Who is initial of combination A and C? That is this person. Done. Okay. So Q is over, Q0 is over, F is over. Still who is pending? Alphabet is pending. And that remains same. 0, 1 both the places. Transition is very important. What is transition? We are going to discuss. Let us take AC. For AC, 0 where it will go, 1 where it will go. How I am going to calculate? I will calculate for A separate. I will calculate for C separate. I will merge both. Have a look. For A, 0. What is the result? A. For C, 0. What is the result? D. So A, 0 is A. For C, 0 is D. Now carefully listen. AC, 0 is AD. That's all. AC, 0 is AD. That's all. The same work you continue for everything. Come on. For 1 I want. A, 1 is B. Done. C, 1 is C. AC, 1 is BC. AC, 1 is BC. In the same way, I am going to do 1 by 1. B, calculated, calculated. Everything I completed. So the conclusion, I made it here, the combination. So, who is E? M1. Who is E? M2. Who is E? M1 intersection M2. It accepts language 1. It accepts language 2. It accepts language L1 intersection L2. Hence, language L1 intersection L2 is regular. Oh, finite automata is possible. That's all the logic. Closer under difference. Difference is also same as your intersection. A slight difference is there. Language L1 is regular, L2 is regular. L1 minus L2 is also regular. It is same as intersection except final state. So I am going to repeat everything same. All the stories, everything is same. Now, what about final state? I have to follow this particular condition. What is that condition? I will prove it once again. Now, we are ready. This is M1, this is M2, and I hope you know what is M1 intersection M2. Starting is AC, ending is not BC. Okay, what is that I am going to say? Come on. Final state of this group should be X comma Y. Who is X? First letter. Who is Y? Second letter. Your first letter should be belongs to final of this machine. Second letter should not be belongs to final of this. Does not belongs to final state. Now you tell me what should be the final state. If I take AC as a final state, A should be final of this, C should not be final of this. Controversy, because first letter should be final of first diagram, second letter should not be final of second diagram. So this is rejected. Let us take BC. B, as per this condition, B must be final of machine 1. C must not belongs to final of this machine 2. It is invalid. Now let us go to AD. What is AD? In AD, A does not belongs to machine 1 final. Rejected. BD, careful. B, first letter, belongs to final of the machine 1. Accepted. Tick. D, must not be belongs to final of the second machine. Accepted. So, the final is here. This is only the discussion in exam. Just if you put BD, it's no more issues. So, L1 minus L2 is regular. What is that meaning? Finite automata is possible for L1. Finite automata is possible for L2. finite automata is possible for L1 minus L2. That is what I made. Closure under reversal. Reverse. In case if L is a regular language, its reverse also will be regular language. We will just see one example. This is your language 1, 1, 0, 1, 1, 0, 1, 0, 1, 1. Tell me its reverse 1, 1, 0, 1, 0, 1, 1, 0, 1, 1, epsilon. Yes, it is your reverse. Come on. 1, 1, 0, 1 available. 0, 1, 1 available. It is also a regular. For this expression possible, for this expression. Can I draw finite automata for this? Yes, sir. Can I draw finite automata for this? Yes, sir. So it is reversal also allowed. Based on this particular reversal, we do have some fundamental properties called basis and induction. For epsilon, reversal will be epsilon. Have a look. For null, reversal will be null. For single letter, reversal will be single letter. Yes. But combination of two letters, reversal will be individual reversal. Concatenation reversal will be individual. Star reversal is same as reversal. This is what the property. Have a look. The last few properties. Closure under homomorphism. Closure under inverse homomorphism. What is that homomorphism? It is something like substituting a string for each symbol. There is a symbol 0. It is related to string of these letters. One is a symbol. It is also related to string of this fellow. For example, I am saying 0 is homomorphism with A, B, B. For example, 1 is homomorphism with B, A. For example, you can have your own. 0 is linked with A, B, B. 1 is linked with B, A. If that is the case, what is 1, 0, 1, 1? I just made it. You please tell me the answer. 1, B, A. 0, A, B, B. 1, B, A. 1, B, A. So this is 1, 0, 1, 1. That's all. This is nothing but homomorphism. If L is a regular language, its homomorphism is also regular. What is inverse homomorphism? Reverse. The same story I brought. Now you should tell me, what is H inverse of this particular term? BA is nothing but 1. ABB is nothing but 0. Come on. BA 1. BA 1. ABB 0. So inverse. H inverse homomorphism. The same story holds good. If T is a regular language, then inverse homomorphism of the T is also regular language. So we have discussed nearly 9 closure property. Its meaning also I discussed in this particular video lecture. Thank you.